March 14, 1943, North Atlantic, 41 degrees N, 52 degrees W. The USS Sentinel never heard it coming. At 3:47 hours, the destroyer escort was 17 hours into convoy duty, running at 12 knots through black water 200 miles southeast of Newfoundland. The engine room hummed with the steady rhythm of twin diesels pushing 1,800 horsepower through reduction gears and into bronze propellers. Below deck, Chief Machinist Kowalski felt the vibration through the steel floor plates, a constant, familiar tremor that every sailor learned to sleep through. Then the tremor stopped. The torpedo struck amidships, port side, 3 feet below the waterline. The explosion tore through fuel bunkers and flooded the forward engine room in less than 90 seconds. Kowalski never made it to the ladder. 23 men went down with the ship. The U-boat that fired the shot was already gone, slipping back into depth and darkness before the survivors hit the water. By dawn, the convoy had lost 2 more escorts. The problem wasn't new. It had been killing ships since 1941. Philadelphia Naval Shipyard, Engine Testing Facility, Building 7. Raymond Archer pushed his mop across the concrete floor at 600, same as he did every morning. The testing bay was empty now, the engineers gone home hours ago, leaving behind oil stains, discarded blueprints, and the metallic smell of overworked machinery. Archer didn't mind the quiet. He preferred it. 32 years old, soft-spoken, invisible to most officers who passed him in the halls, just another janitor in Navy dungarees keeping the floors clean while better men solved the war. But Archer had been watching. For 6 months, he'd worked the night shift in Building 7, mopping around engineers who barely noticed him. He'd seen them test engine after engine, mounting diesel motors onto reinforced steel frames, running them at full throttle while technicians measured noise output with hydrophones submerged in water tanks. The goal was simple: reduce the acoustic signature of destroyers and escorts so German submarines couldn't hear them coming. The results were not simple, they were failing. Every proposed solution, rubberized mounts, spring isolators, layered dampening pads, reduced vibration on paper but fell apart under sustained operation. The rubber cracked in salt water. The springs fatigued after weeks at sea. The pads compressed and lost effectiveness. Ships were still being detected at ranges exceeding 8 miles, giving U-boats time to position, calculate firing solutions, and vanish before the convoy even knew it was under attack. The mathematics were brutal. In the first 2 months of 1943 alone, German submarines sank 47 Allied merchant vessels and 11 escorts in the North Atlantic. The oil those ships carried never reached Britain. The troops aboard never made landfall. The war effort was hemorrhaging resources faster than industry could replace them, and the Kriegsmarine was winning the acoustic battle beneath the waves. Archer had listened to the engineers argue. He'd heard Lieutenant Morrison, the lead acoustics officer, bark orders at junior technicians who couldn't make the dampening systems work. He'd watched them tear apart engine mounts in frustration, heard them swear that the solution existed somewhere in material science or mechanical geometry, if only they had time to find it. But time was the one thing they didn't have. Archer wrung out his mop and leaned it against the wall. The testing bay held a disassembled diesel motor on a workbench, its components spread across steel tables like pieces of an unsolved puzzle. Beside it sat a water tank, 12 feet long and 4 feet deep, designed to simulate ocean conditions. Hydrophones dangled inside, wired to oscilloscopes that translated vibration into visual waveforms. He walked closer. The motor mount, the steel frame that held the engine in place, was bolted to a platform designed to replicate a ship's hull. Beneath it, engineers had installed the latest dampening prototype, a system of laminated rubber pads compressed between steel plates. Archer crouched, examining the contact points where metal met rubber. The material was already showing stress fractures. Under real-world conditions, this system would fail in less than a month. He reached into his pocket and pulled out a cigarette, then stopped. Smoking wasn't allowed near fuel residue. He put it back. Instead, he picked up one of the oil rags draped over the workbench. The rag was heavy, saturated with machine oil from the motor's last test run. Archer squeezed it, feeling the weight of the petroleum-soaked cotton fibers. The oil didn't drip, it clung, absorbed into the fabric's weave. He set the rag down on the steel mounting plate and pressed his palm against it. Soft, pliable, dense. He pressed harder. The oil redistributed under pressure, spreading through the rag's fibers but maintaining shape. It didn't compress flat like rubber. It didn't spring back like foam. It simply adapted. Archer stood, staring at the rag for a long moment. Then he looked at the engine mount. Office of Naval Engineering, 3rd floor, 8:30 hours. Lieutenant Morrison sat behind a desk buried under technical reports, requisition forms, and classified memos from the Bureau of Ships. He was 41 years old, MIT educated, and responsible for solving a problem that was costing lives every day. The pressure was visible in the lines around his eyes, the way his jaw tightened when another test failed, the way his hand shook slightly when he lit his morning cigarette. A knock at the door. "Come." A petty officer stepped inside, holding a clipboard. "Sir, the overnight acoustics test results." Morrison took the clipboard without looking up. He scanned the data, frequency analysis, decibel measurements, comparative vibration indices. Every number told the same story. The new dampening system reduced noise output by 18%, not enough. German hydrophones could still detect the signature at ranges exceeding 6 miles. Operational doctrine required detection ranges below 3 miles to be tactically viable. They were failing by a margin of 100%. Morrison dropped the clipboard onto his desk. "Schedule another test for Thursday. Different compression ratio on the rubber." "Yes, sir." The petty officer left. Morrison leaned back in his chair and closed his eyes. Somewhere in the Atlantic, another convoy was steaming toward Europe, engines humming, propellers churning, broadcasting their location to every enemy submarine within listening range. And there was nothing he could do to stop it. Building 7, 21:30 hours. Archer returned to the testing bay after the engineers went home. He worked alone, moving quietly, his hands steady. From the supply closet, he retrieved a stack of clean cotton rags, standard-issue shop towels used for machinery maintenance. He carried them to the workbench, then walked to the oil drum in the corner and filled a steel pan with 30-weight motor oil. One by one, he submerged the rags, letting them soak. The oil saturated the fibers slowly, spreading through the cotton weave like ink through paper. Archer squeezed each rag, forcing the oil deeper, ensuring even distribution. When he finished, he had 12 oil-soaked rags, each one heavy and dark, dripping slightly but holding shape. He carried them to the engine mount. The existing rubber dampening pads were still bolted in place. Archer didn't remove them, not yet. Instead, he layered the oil rags on top, folding them into compact rectangles and positioning them beneath the motor's mounting feet. He worked methodically, adjusting placement, testing compression by hand. When he was satisfied, he stepped back. The rags sat compressed beneath the engine's weight, oil seeping slightly at the edges but maintaining integrity. They looked absurd, improvised, unscientific, something a mechanic might use as a temporary fix in a rural garage, not something that belonged in a naval engineering facility designing solutions for a world war. Archer checked the hydrophones in the water tank, still functional. He checked the oscilloscope connections, intact. Then he walked to the motor's ignition panel and flipped the starter switch. The diesel engine roared to life. Vibration pulsed through the mounting frame, transmitted down into the platform, radiating outward toward the water tank. The hydrophones picked up the acoustic signature immediately, translating mechanical energy into electrical signals that appeared as jagged waveforms on the oscilloscope screen. Archer watched the display. The waveform was lower, smoother. The peaks, sharp spikes that represented high-frequency vibration were dampened, compressed into softer curves. He increased throttle. The engine climbed to 1500 RPM, the sound filling the testing bay, echoing off concrete walls. But the oscilloscope showed something different. The acoustic signature remained suppressed, the oil-soaked rags absorbing vibration in ways the rubber pads never could. Archer let the motor run for 10 minutes, monitoring the readings, watching for signs of failure or degradation. The oil rags held. He shut down the engine and stood in the sudden silence, staring at the oscilloscope screen. The data was still visible, frozen in the phosphorescent glow, a 34% reduction in transmitted vibration compared to the baseline rubber system. 34%. Archer looked at the oil rags compressed beneath the engine mount, simple, improvised, made from materials that cost less than $5. Then he looked at the door, knowing that what he'd just done was unauthorized, unscientific, and completely outside the boundaries of his job. But the numbers didn't lie. He walked to the supply closet, retrieved a notebook, and began writing down everything he'd just done: measurements, materials, observations. His handwriting was careful, methodical, the notes of a man who understood that what he'd discovered might matter, or might get him thrown off the base. Outside, the night shift changed over. Somewhere in the Atlantic, another convoy steamed into darkness, engines humming, waiting for the sound of torpedoes. Archer closed the notebook and slipped it into his jacket. Tomorrow, he would have to decide what to do with what he knew. End of Chapter 1. Chapter 2, The Hierarchy of Doubt. March 15, 1943, Philadelphia Naval Shipyard, 7:45 hours. Archer arrived early. He stood outside Lieutenant Morrison's office holding the notebook under his arm, rehearsing what he would say. The words felt inadequate in his mind. A janitor explaining engineering to a man with an MIT degree, presenting data gathered during unauthorized testing with equipment he wasn't trained to operate. The absurdity of it pressed against his chest like physical weight. But the numbers were real. 34% reduction in transmitted vibration. Sustained performance over 10 minutes of continuous operation. Materials that cost almost nothing and could be implemented immediately across the entire fleet. If he was right, if the oil-soaked rags actually worked under real-world conditions, then men would stop drowning in the Atlantic. That had to mean something. The office door opened. Lieutenant Morrison stepped out, coffee cup in hand, his uniform crisp despite the early hour. He glanced at Archer without recognition, the way officers look through enlisted men whose names they've never learned. "Sir," Archer said, "I need 2 minutes." Morrison stopped. His eyes moved to the mop bucket Archer had left near the wall, then back to Archer's face. "Your maintenance." "Yes, sir. Night shift, Building 7. "Then speak to your supervisor about whatever issue." "It's about the acoustic dampening tests, sir." Morrison's expression shifted slightly. Not interest, caution. "The tests are classified, sailor. You shouldn't even know they exist." "I work in the testing bay, sir. I've been watching the failures for 6 months." A pause. Morrison's jaw tightened. Around them, the hallway filled with morning foot traffic, officers moving between departments, petty officers carrying requisition forms, the mechanical rhythm of a naval shipyard waking up. Morrison glanced at his watch. "You have 90 seconds. Archer opened the notebook. "Last night I ran an unauthorized test using oil-saturated cotton rags as vibration dampeners. The results showed a 34% reduction in acoustic transmission compared to the current rubber pad system." Morrison stared at him. "You ran a test?" "Yes, sir." Without authorization. Yes, sir. Using naval equipment, after hours in a restricted facility. Archer held the notebook steady. The data is documented. Every measurement, material specification, and procedural step. The oil rags absorb vibration more efficiently than any synthetic dampening system currently in development. Morrison took the notebook. He flipped through the pages, his expression unreadable. Archer had written everything in precise technical language: compression ratios, frequency analysis, material density calculations. The handwriting was careful, almost obsessive in its clarity. Morrison closed the notebook and handed it back. "Sailor, do you understand what you've just admitted to? Unauthorized access to restricted equipment, conducting experiments outside your clearance level, wasting naval resources on," he gestured at the notebook, "on shop rags and motor oil." "The system works, sir." "You don't know that. You ran one test for 10 minutes in a controlled environment. Real-world conditions are exponentially more complex. Saltwater corrosion, thermal cycling, sustained mechanical stress over weeks at sea. Then test it properly, sir. Give me access to." "You're a janitor." Morrison's voice cut through the hallway noise, sharp and final. "You don't have an engineering degree. You don't have technical training. You don't have authorization to touch that equipment, let alone redesign dampening systems that actual engineers have spent months developing." Archer felt the weight of every eye in the hallway turning toward them. He kept his voice level. "With respect, sir, the actual engineers are failing." Silence. Morrison's face went rigid. For a moment, Archer thought he'd be arrested. Then Morrison leaned closer, his voice dropping to a whisper that somehow felt louder than shouting. "Get back to your mop, sailor. And if I hear you've touched that equipment again, I'll have you on report so fast you'll be swabbing latrines in the Aleutians by the end of the week." Morrison turned and walked away, disappearing into his office. The door closed with a precise, dismissive click. Archer stood alone in the hallway, holding his notebook. Around him, the shipyard continued moving. Nobody stopped. Nobody asked questions. He was invisible again, just a janitor holding a mop bucket, indistinguishable from 1,000 other enlisted men whose ideas didn't matter. He looked down at the notebook in his hands. Then he walked back toward Building 7. Office of Naval Engineering, conference room, 10:30 hours. Morrison sat at the head of the table, surrounded by 6 engineers and 2 Bureau of Ships liaisons. The morning briefing had been running for 40 minutes, cycling through the same problems with no new solutions. Acoustic signature reduction remained the priority. Progress remained non-existent. Commander Talbot, the senior liaison, tapped his pen against the table. "We're 8 weeks behind schedule, Lieutenant. The Admiral wants results." "We're aware of the timeline, sir." "Then, why are we still seeing detection ranges above 6 miles? Morrison glanced at the reports spread across the table: test data, material analyses, failure assessments. Every document told the same story. The rubber compounds degrade faster than predicted. Saltwater exposure accelerates molecular breakdown. We've tried 17 different formulations." "Then try 18. Sir, with respect, we're approaching the limits of what synthetic materials can achieve under these conditions." Talbot leaned forward. "Then find new materials." Morrison said nothing. Around the table, the other engineers stayed silent, staring at their notes, avoiding eye contact. Nobody wanted to admit what they all knew: they were out of ideas. Talbot stood. "The Atlantic convoys are bleeding, Lieutenant. Every day we delay, more ships go down. I don't care if you have to invent a new branch of physics. Find a solution." He left, the door closed. Morrison sat alone with his engineers. One of them, Lieutenant Junior Grade Peterson, fresh from Caltech, broke the silence. "What if we revisited the spring isolation concept? If we adjust the tensile strength?" We tried that in January. The spring's fatigued after 3 weeks. Different alloy, different failure mode, same timeline. Peterson fell silent. Morrison looked around the table at the exhausted faces of men who'd been working 16-hour days for months, chasing a solution that seemed to exist just beyond reach. Smart men, educated men, men who understood acoustics, materials science, mechanical engineering. Men who were failing. He thought about the janitor in the hallway. The absurdity of it, a maintenance worker with a notebook full of observations, suggesting that oil rags could solve what MIT engineers couldn't. Morrison had dismissed him immediately. Of course he had. The man had no credentials, no training, no authority. He'd conducted unauthorized tests in a restricted facility. By every regulation, Morrison had been right to shut him down. But the number kept echoing in his mind. 34%. Morrison stood abruptly. Meeting adjourned, get back to work. The engineers filed out. Morrison remained, staring at the reports on the table, seeing the pattern they'd all been avoiding. Every solution they'd tried was sophisticated, engineered, designed according to established principles of material science. And every single one had failed. Building 7, 1,400 hours. Archer worked methodically, cleaning the testing bay in silence. The morning's confrontation replayed in his mind, Morrison's dismissal, the way the lieutenant had handed back the notebook like it was contaminated. The message had been clear. Stay in your lane, know your place, leave the thinking to people with degrees. He understood the hierarchy. He'd been Navy for 11 years, long enough to know that enlisted men didn't question officers, maintenance workers didn't lecture engineers, and janitors definitely didn't redesign naval systems. But he also understood machinery. Archer had grown up in rural Pennsylvania, learning mechanics in his father's garage, fixing tractors, rebuilding truck engines, solving problems with whatever materials were available because buying new parts wasn't an option. He'd learned to observe, to test, to iterate. No textbook, no theory, just hands-on intuition built from 10,000 hours of trial and error. The Navy had assigned him to maintenance. Fine. He cleaned floors, emptied trash, kept the facilities running. But he'd never stopped watching, never stopped learning. For 6 months, he'd observed engineers struggle with the acoustic problem, watched them approach it with sophisticated mathematics and material science while missing something fundamental. Vibration wasn't just about material hardness or spring constants. It was about energy absorption and redistribution. The oil-soaked rags worked because they combined 3 properties simultaneously: density from the cotton fibers, viscosity from the oil, and adaptability from the fluid dynamics of petroleum under pressure. It was simple, inelegant, something a mechanic would improvise in a field repair. Which was exactly why the engineers had never considered it. Archer finished mopping and checked the testing bay. Empty. The diesel motor sat on its mount, the rubber dampening pads still in place, showing the same stress fractures they'd had yesterday. Beside it, hidden in a supply cabinet, were the 12 oil-soaked rags he'd used for his test. He looked at them for a long moment. Morrison had ordered him to stay away from the equipment. Direct command from a superior officer. Disobeying meant disciplinary action, possible court-martial, the end of his naval career. But the convoys were still sailing, the U-boats were still hunting, men were still dying. Archer closed the cabinet and walked to the time clock, punching out at the end of his shift. Tomorrow night he would decide. North Atlantic, Convoy HX-229, March 16, 1943, 200 hours. The USS Bainbridge steamed through darkness, engines humming at 12 knots, escorting 42 merchant ships carrying fuel, ammunition, and troops toward Britain. Sonarman's second-class Murphy sat in the sound room. Headphones clamped over his ears, listening to the ocean. He heard the destroyer's own propellers, a steady, rhythmic thrum. He heard the merchant ship's slower, heavier signatures scattered across the convoy formation. He heard the ambient noise of the Atlantic, wave action, biological sounds, the distant groan of shifting water pressure. And then he heard something else. A faint mechanical pulse, low frequency, diesel engine signature bearing 270, range estimated at 8 miles. Murphy keyed the intercom. Con sonar, possible submarine contact bearing 270. The response was immediate. General quarters sounded throughout the ship. Men rushed to battle stations. The Bainbridge turned toward the contact, increasing speed, preparing to engage. But the U-boat had already heard them first. 8 miles away, U-558 had been tracking the convoy for 3 hours, listening to the destroyer escorts broadcast their positions with every revolution of their propellers. Captain Lieutenant Kretsch didn't need to see the ships. He could hear them clearly through his hydrophone operator's reports, plotting their courses, calculating firing solutions. The Bainbridge was turning toward him now, but too late. Kretsch gave the order. Tubes 1 and 2 fired. 2 torpedoes streaked through black water at 46 knots, tracking toward the merchant ship SS Robert E. Peary, loaded with aviation fuel. The Peary never stood a chance. The first torpedo struck at 2:14 hours. The second hit 18 seconds later. Aviation fuel ignited instantly, turning the merchant ship into a floating inferno visible for 20 miles. 73 men died in the initial explosion. The survivors who made it into the water burned anyway, the ocean itself on fire. The Bainbridge dropped depth charges, but U-558 was already gone, diving deep and slipping away into the acoustic chaos created by the burning wreckage. By dawn, the convoy had lost 4 ships. The pattern continued. Philadelphia Naval Shipyard, Building 7, March 17, 1943, 2200 hours. Archer returned to the testing bay after dark. He moved quietly, checking the hallways, ensuring he was alone. The shipyard operated 24 hours, but Building 7 was empty during third shift. No engineers, no supervisors, just the night maintenance crew scattered across other facilities. He walked to the supply cabinet and retrieved the oil-soaked rags. Then he carried them to the engine mount and began working. This time he would run a proper test. Not 10 minutes, 2 hours. Not a single throttle setting, full operational range. He would document everything, measure every variable, prove that the system worked under conditions that mimicked real-world naval deployment. And if Morrison still refused to listen, Archer would find someone who would. He positioned the rags beneath the motor mounts, layered them carefully, adjusted compression. He checked the hydrophones, calibrated the oscilloscope, verified that the water tank simulated proper acoustic transmission conditions. Then he started the engine. The diesel roared to life, vibration pulsing through the mounting frame. Archer watched the oscilloscope, monitoring the acoustic signature, nodding the suppressed waveform. He increased throttle gradually, testing the system across the full operational spectrum: idle, cruising speed, maximum output. The oil rags held. He let the motor run, settling into the rhythm of observation and documentation, filling page after page of the notebook with data that would either vindicate him or end his career. Outside, the night deepened. Somewhere in the Atlantic, another convoy steamed toward Europe. And in a testing bay in Philadelphia, a janitor worked alone, trying to save them. End of Chapter 2. Chapter 3, The Witness. March 17, 1943. Philadelphia Naval Shipyard, Building 7, 23:45 hours. The diesel engine had been running for 90 minutes. Archer stood beside the oscilloscope, watching the waveform flatten and spike in rhythmic patterns. Every 15 minutes, he adjusted the throttle, testing the oil rags under different load conditions, recording acoustic signatures, monitoring for degradation. The data was consistent. At idle, the system reduced vibration by 31%. At cruising speed, 34%. At maximum output, 29%. Better than any synthetic dampening system currently in testing. He marked the readings in his notebook, his handwriting precise despite the hour. Outside, the shipyard was quiet, just the distant sound of welding torches in the fabrication halls and the occasional footsteps of security patrols making their rounds. Archer checked his watch. 23:47 hours. 13 more minutes, then he'd shut down and document final observations. By morning, he'd have irrefutable proof that the system worked under extended operational conditions. Then a voice cut through the engine noise. "That's an unauthorized test." Archer spun around. Chief Petty Officer Wade stood in the doorway, arms crossed, his face unreadable in the dim lighting. He was 52 years old, 28 years Navy, a machinist who'd worked his way up from the engine rooms of destroyers to a supervisory position at the shipyard. Unlike Morrison, Wade knew Archer's name. "Chief," Archer's hand moved toward the ignition switch. "Don't shut it down yet." Wade stepped closer, his eyes moving from the running engine to the oscilloscope to the notebook on the workbench. "How long have you been running this?" 93 minutes, Chief." Wade walked around the engine mount, crouching to examine the oil-soaked rags compressed beneath the motor's feet. He pressed his palm against the steel frame, feeling the vibration. Then he stood and looked at the oscilloscope display. "What's the reduction percentage?" Archer hesitated. Admitting the numbers meant admitting everything: the unauthorized tests, the equipment access, the direct violation of Morrison's order. Wade waited. 34% at cruising load, Chief." Wade's expression didn't change. He walked to the water tank and tapped the hydrophone housing, checking the mounting integrity. Then he picked up Archer's notebook and flipped through the pages, reading the technical annotations with the practiced eye of someone who'd spent decades troubleshooting machinery at sea. Finally, he set the notebook down. "You talked to Lieutenant Morrison yesterday." "Yes, Chief." "He ordered you to stay away from this equipment." "Yes, Chief." "And here you are, running a 2-hour thermal stress test with materials you requisitioned without authorization." Wade's voice was flat, procedural. "You understand that's a court-martial offense." Archer met his eyes. "The system works, Chief. The convoys are dying because nobody's willing to test something that doesn't come with an engineering degree attached to it." "You think Morrison's an idiot?" "I think he's trapped by doctrine." Wade stared at him for a long moment. Then he walked to the engine controls and increased the throttle himself. The diesel roared louder, vibration intensifying, the acoustic signature climbing on the oscilloscope display, but still suppressed, still dampened by the oil-soaked rags absorbing energy that would otherwise radiate through the hull and into the water. Wade let it run for 30 seconds, then reduced throttle back to cruising speed. "I was a machinist's mate on the Reuben James," he said quietly. "November 1941. We were escorting a convoy when a U-boat put a torpedo into our port side. The ship went down in 5 minutes. 44 men made it off. 115 didn't." Archer said nothing. Wade turned to face him. "You know why we got hit? Because the U-boat heard us coming from 8 miles out. We were broadcasting our position with every turn of the screws, might as well have been firing flares. By the time sonar picked them up, they'd already fired." He walked back to the oscilloscope. "Morrison's not trapped by doctrine. He's trapped by failure. He's been trying to solve this problem for 8 months with every resource the Navy can give him, and nothing works. You show up with shop rags and motor oil, and suddenly the numbers drop by a third." Wade picked up the notebook again. "That doesn't make him feel vindicated. It makes him feel humiliated." So what do I do, Chief? You finish this test, you document everything, and then you let me handle Morrison. Archer blinked, Chief. Wade handed him the notebook. I've got enough rank to make him listen and enough scars to make him believe me, but I need data that'll survive scrutiny, not just one night of testing. I need sustained performance, thermal cycling, saltwater exposure simulation, failure mode analysis. That'll take at least a week. Then you've got a week. Off the books, third shift only, and if anyone asks, you're cleaning the bay. Wade walked toward the door, then stopped. One more thing, Archer. If this works, if we actually implement this across the fleet, your name won't be on it. Morrison will take credit, the Bureau of Ships will take credit, maybe I'll get a commendation for field oversight. But you'll still be mopping floors. I don't care about credit, Chief. Wade studied him. No, I don't think you do. He pushed open the door. Get back to work. The door closed. Archer stood alone in the testing bay. The diesel engine still running. The oscilloscope still recording data that might save lives or end his career. He looked down at the notebook in his hands. Then he picked up his pencil and continued documenting. Chapter 4, The Proof. March 24, 1943. Philadelphia Naval Shipyard, Building 7, 8:30 hours. Lieutenant Morrison sat in the observation room, watching through reinforced glass as the test engine ran at maximum output. Beside him, Chief Wade stood with his arms crossed, silent. On the other side of the glass, Archer adjusted monitoring equipment, his movements precise and methodical. 7 days of testing, 168 hours of accumulated data, thermal cycling from 40 degrees to 120, simulated saltwater spray, vibration analysis across the full operational spectrum. The oil-soaked rags had not failed. Morrison stared at the oscilloscope readings displayed on the panel in front of him. Average acoustic reduction, 32%. No material degradation. No compression failure. No loss of dampening efficiency over extended operation. It was impossible. Except the data said otherwise. Wade broke the silence. Lieutenant, we need to talk about implementation. Morrison didn't look away from the display. This is a field expedient, a temporary fix using improvised materials. It's not. It's a solution. Wade's voice carried the weight of 3 decades at sea. The rubber systems are failing after 3 weeks. This has been running continuously for 7 days with no performance loss. We don't know how it'll perform in actual combat conditions. Then we test it in actual combat conditions. Morrison finally turned to face him. You're suggesting we install an unproven system, designed by a janitor, onto active naval vessels. I'm suggesting we stop letting doctrine kill sailors while we wait for a perfect solution that doesn't exist. Wade gestured toward the test bay. That man has solved the problem. The only question is whether you're willing to admit it. Morrison's jaw tightened. Through the glass, he watched Archer recording measurements, the same careful precision he'd shown for 7 straight days. No complaints, no demands for recognition, just methodical documentation of a system that worked. If this fails at sea, Morrison said quietly, men die, and that failure is on me. If we don't implement it, men die anyway. That's also on you. The 2 officers stared at each other. Finally, Morrison stood. I want full materials analysis. Petroleum viscosity under temperature variation, cotton fiber tensile strength, long-term degradation projections. And I want comparison testing against every synthetic system we've developed. Lieutenant, if this works, Chief, then it works by mechanism, not magic. I want to understand why before I stake lives on it. Morrison walked toward the door, then paused. And get Archer proper clearance. If we're doing this, we're doing it right. Wade allowed himself the smallest smile. Yes, sir. April 2, 1943, Bureau of Ships, Washington, D.C. The conference room held 12 officers, 2 civilian engineers, and enough technical documentation to fill a filing cabinet. At the head of the table, Rear Admiral Cochrane reviewed the test results with the methodical attention of a man who'd spent 40 years in naval engineering. Morrison stood at ease, waiting. Finally, Cochrane set down the report. 32% average reduction. Yes, sir. Using cotton rags and motor oil. Yes, sir. Developed by a maintenance worker with no formal engineering training. Morrison hesitated only slightly. Yes, sir. Cochrane leaned back in his chair. Gentlemen, does anyone want to explain to me how we've spent 8 months and $2 million developing synthetic dampening systems that don't work, while a sailor mopping floors solved the problem with materials that cost $5? Silence. One of the civilian engineers, a thin man from General Electric, cleared his throat. Admiral, with respect, the solution is elegant but not scalable. Manufacturing oil-dampened systems for the entire fleet would require. We're not manufacturing anything, Cochrane interrupted. Every ship already has cotton rags. Every ship already has motor oil. We're talking about implementation using existing supplies. But, sir, quality control will be handled through training and inspection protocols, same as every other maintenance procedure. Cochrane looked at Morrison. Lieutenant, what's your recommendation? Morrison took a breath. Immediate fleet-wide implementation, starting with Atlantic convoy escorts. We establish standardized procedures, train engine room crews, monitor performance, and adjust as needed. It's not perfect, but it's operational. Estimated timeline: 30 days for initial deployment, 90 days for comprehensive fleet integration. Cochrane nodded slowly, then he looked at the other officers around the table. Any objections? No one spoke. Then make it happen. Cochrane stood, signaling the end of the meeting. As the room cleared, he gestured for Morrison to remain. Lieutenant, one question. Sir? The sailor who developed this, what's his name? Morrison met his eyes. Raymond Archer, sir, machinist's mate 3rd class. See that he gets promoted and transferred to a technical position where we can actually use his brain instead of his mop. Yes, sir. Cochrane picked up the report again, shaking his head. Cotton rags and motor oil, Christ. Morrison left the room, walked down the marble halls of the Bureau of Ships, and stepped outside into April sunshine. Somewhere in the Atlantic, the convoys were still sailing. But now maybe they had a chance. End of Chapter 4. Chapter 5, First Blood. April 28, 1943. USS Harding, Mid-Atlantic, 52 degrees N, 31 degrees W. The destroyer escort had been retrofitted in Philadelphia, 3 weeks of work compressed into 10 days. Engine room crews trained on the new dampening protocol, oil-soaked cotton rags, specific compression ratios, replacement intervals every 48 hours. Simple enough that any machinist could implement it. Cheap enough that supply shortages weren't a concern. Now the Harding steamed through the North Atlantic on her first convoy escort mission since installation. 38 merchant ships spread across 10 square miles of ocean, bound for Liverpool with fuel and ammunition. In the engine room, machinists made second-class tours knelt beside the starboard diesel mount, checking the oil rags compressed beneath the engine's feet. They looked absurd, improvised, something you'd expect to see in a rural garage, not a United States Navy warship. But the vibration meters told a different story. Acoustic signature down 30% from baseline. Tours had been skeptical when Chief Wade briefed them on the system. Cotton rags, motor oil. It sounded like something a desperate mechanic would try when real parts weren't available. But Wade had looked him in the eye and said 5 words that changed everything. This will save your life. Now running silent through U-boat hunting grounds, Tours believed him. On the bridge, Captain Reeves studied the convoy formation through binoculars. 40 hours into the crossing, no contacts, no attacks. Intelligence reported 3 wolf packs operating in this sector, but so far the convoy had slipped through undetected. Below in the sound room, sonarman First Class Kowalski, no relation to the chief who died on the Sentinel, listened through headphones, monitoring the ocean. He heard the Harding's own propellers, quieter than they should be, the acoustic signature suppressed by whatever magic the engineers had worked on the engine mounts. He heard the merchant ships, their deeper, slower rhythms. He heard the ambient noise of the Atlantic, biological sounds, wave action, thermal layers shifting. No submarines. Kowalski keyed the intercom. Con sonar, no contacts. Sonar con, maintain search. The hours passed, the convoy steamed east. U-558, depth 60 meters, 340 hours. Captain Lieutenant Kretsch stood in the control room, listening to his hydrophone operator's reports. They'd been tracking convoy patterns for 2 days, positioning themselves along the expected route, waiting for the sound signatures that always betrayed Allied ships long before visual contact. But tonight, something was different. Herr Kapitän, the operator said, frowning. I'm picking up merchant traffic bearing 090, but the escort signatures are weak. Define weak. Reduced acoustic profile. I can hear the merchants clearly at 12 kilometers, but the escorts are barely registering at 6. Kretsch moved to the hydrophone station, taking the headphones himself. He listened, filtering through the ocean noise, isolating the mechanical sounds. The operator was right. The merchant ships broadcast their positions clearly, heavy diesel signatures, predictable rhythms. But the destroyer escorts, normally just as loud, were somehow muted. New propeller design, the navigator suggested. Propellers don't reduce engine noise, Kretsch said. Something else. He made a decision. Come to periscope depth, we close to visual range. U-558 rose slowly, the deck tilting upward, ballast tanks blowing. At 18 meters, Kretsch raised the periscope and swept the horizon. There, the convoy, exactly where the hydrophones predicted, but closer than it should be. The escorts had approached within 4 kilometers before U-558 detected them, half the normal range. Kretsch lowered the periscope. They've done something to their engines, sound dampening. The control room fell silent. If the Allies had found a way to reduce acoustic signatures, the entire tactical advantage of submarine warfare shifted. U-boats relied on hearing convoys long before being seen, calculating intercept courses, positioning for attack. If that detection range collapsed from 12 kilometers to 4. Orders, Herr Kapitän. Kretsch stared at the chart table. 4 kilometers was knife-fighting range. The escorts would have active sonar, radar, depth charge racks. Closing to torpedo range meant exposing U-558 to immediate counterattack. But command needed to know what the Allies had developed. Track the convoy, maintain distance, we observe and report. U-558 descended back into darkness, following the convoy by the faint acoustic signatures that remained, no longer hunting but watched. The balance was shifting. USS Harding, 600 hours. Captain Reeves stood on the bridge wing, drinking coffee as dawn broke over the Atlantic. Behind him, the convoy stretched across calm seas, every ship accounted for, no distress signals, no torpedo explosions. 42 hours into the crossing, normally the most dangerous window, and they'd passed through unmolested. Chief Wade climbed to the bridge, carrying a clipboard. Morning report, Captain. Engine room confirms dampening system performing within specifications. No degradation, no maintenance issues. Reeves nodded. Sonar contacts. None since departure. That's not normal. No, sir, it's not. They stood in silence, watching the sun climb. Both men understood what the quiet meant. Either they'd gotten lucky and avoided the wolf packs, or something fundamental had changed. The Harding had crossed the same waters where ships had been dying for 2 years, and nothing had touched them. "Chief," Reeves said quietly, "how did this system get developed? The briefing materials were vague." Wade considered his answer. Enlisted man at the Philadelphia yard. Observed the problem, tested a solution, proved it worked. Engineer. Janitor. Reeves turned to look at him. "You're telling me a maintenance worker solved what MIT couldn't?" "I'm telling you that sometimes the people closest to the machinery see things the designers miss." Wade tapped the clipboard. He noticed that oil-soaked rags absorbed vibration better than synthetic compounds. Nobody with a degree thought to test it because it wasn't sophisticated enough. "What's his name?" "Archer, Raymond Archer." "Is he being recognized?" Wade's expression didn't change. "He got promoted to machinist's mate second class and transferred to technical liaison. That's more recognition than most enlisted men ever see." Reeves understood what wasn't being said. The Navy would credit the engineers, the officers, the institutional research programs. The man who actually solved the problem would disappear into the records as a footnote, if that. "Make sure it's documented," Reeves said. "Somewhere official. I don't care if his name ends up in the history books, but it needs to be in the file." "Yes, sir." Below them, the Harding's engines hummed quietly, pushing the ship through water at 12 knots, broadcasting almost nothing, a ghost sliding through hunting grounds that had claimed dozens of escorts. The convoy steamed on. By nightfall, they would pass the halfway point. By this time next week, similar systems would be installed on 30 more escorts. By summer, the entire Atlantic fleet. The wolf packs were still hunting. But now, the prey had learned to move in silence. Chapter 6: The Turning. May 15, 1943, Admiralty Building, London. Commander Blackwell studied the chart spread across the briefing table. Colored pins marking convoy routes and U-boat contacts. 6 weeks of data, compiled from destroyer escorts operating with the new dampening system. The pattern was unmistakable. "Convoy losses are down 41%, he said, addressing the assembled officers. U-boat kill rates have dropped from an average of 8 ships per wolf pack engagement to 3. Detection ranges have collapsed from 12 kilometers to under 5. An operations officer leaned forward. "What changed?" "The Americans developed an acoustic dampening system. Simple, cheap, effective. They've installed it across their Atlantic fleet." "What's the technology?" Blackwell allowed himself a slight smile. "Cotton rags soaked in motor oil, compressed under engine mounts." Silence. "You're joking," someone said. "I'm not. The U.S. Navy tested it for 3 weeks, validated the results, and implemented it fleet-wide in under 60 days. We've received technical specifications and training protocols. Installation begins on Royal Navy escorts next week." The same officer who'd questioned the technology shook his head. "How did we miss something that simple?" "Because we were looking for complex solutions to a complex problem. Someone with no formal training looked at it differently." Blackwell tapped the chart. "The point is, it works, and it's changing the Atlantic battle." He gestured to the statistical summary. "In April, before implementation, we lost 34 merchant ships to U-boat attack. In May, with partial fleet coverage, we've lost 19. Projection for June with full implementation, under 12. The room absorbed the numbers. "Gentlemen, we're winning. For the first time since 1940, the math is on our side." U-Boat Command, Lorient, France, May 18, 1943. Admiral Dönitz read the after-action reports with mounting frustration. 8 patrol boats, 14 attacks, only 9 confirmed kills. Detection ranges had collapsed. Convoys were slipping past patrol lines that should have heard them from 20 kilometers out. His intelligence officer stood at attention. "Herr Admiral, we've confirmed the cause. The Allies have implemented acoustic dampening on their escort vessels." "What kind of dampening?" "Unknown, sir, but effective. Our boats report difficulty tracking escorts until they're within visual range." Dönitz set down the reports. "If we can't hear them, we can't intercept them. If we can't intercept them, we can't sink them." He looked at the map on the wall, showing the Atlantic convoy routes. "How long until all their escorts are equipped?" "Intelligence estimates 60 to 90 days for complete fleet integration." 3 months. Dönitz did the math in his head. If convoy losses continued dropping at the current rate, the Atlantic blockade would fail. Britain would survive. The American supply lines would hold. And the U-boat fleet, the one weapon Germany had that could strangle the Allied war effort, would become obsolete. "Increase patrol density," he said. "Closer intercepts, visual confirmation before acoustic tracking, and get our engineers working on countermeasures." The officer saluted and left. Dönitz stood alone, staring at the map, understanding that the Battle of the Atlantic had just shifted in ways that statistics couldn't capture. Somewhere, somehow, the Allies had found an advantage. And in naval warfare, advantages compound fast. The hunters were becoming the hunted. Philadelphia Naval Shipyard, Technical Liaison Office, June 3, 1943. Archer sat at a desk that still felt foreign, reviewing implementation reports from 37 ships now operating with the dampening system. The promotion had come with new responsibilities: training crews, troubleshooting problems, refining procedures. He wore the rating badge of machinist's mate second class now, and people actually listened when he spoke. But the work was the same, solving problems that others overlooked. Chief Wade knocked on the doorframe. "Got a minute?" "Always, Chief." Wade stepped inside, closing the door. He dropped a folder on the desk. "Latest Atlantic convoy statistics. Losses down 43% since implementation. U-boat kill rates dropping every week." Archer opened the folder, scanning the numbers. Lives saved, translated into data points and percentages. Ships that made it to Britain with fuel and ammunition because submarines couldn't hear them coming. "How many escorts are equipped now?" he asked. 84 in the Atlantic, 42 in the Pacific, full fleet integration expected by August. Wade sat down. "You did that. You understand that, right?" Archer looked up. "A lot of people did that. Morrison validated the testing. You convinced him to implement it. The Bureau approved deployment. You solved the problem." Wade's voice was firm. "Everyone else just got out of the way." Archer set down the folder. "Chief, my name's not in any report. Morrison gets credit in the technical documentation. The Bureau takes credit in the strategic assessments. I'm just listed as Technical Liaison Acoustic Systems." "Does that bother you?" "No," Archer meant it. "I grew up fixing tractors in Pennsylvania. Nobody cares who repairs a machine, they just care that it works. This is the same thing. Bigger scale, but the same principle." Wade studied him for a long moment. "You're a strange man, Archer." "I just pay attention, Chief." "That's rarer than you think." Wade stood, picking up the folder. "For what it's worth, there's a file in the Bureau archives. Classified, detailed technical documentation of the development process. Your name's in there. Someday, someone will read it." "Someday's a long time, Chief." "Yeah, it is." Wade walked to the door, then paused. "The Reuben James, the ship I was on when it got torpedoed. We lost 115 men because a U-boat heard us coming from 8 miles out." He looked back at Archer. "How many ships have crossed the Atlantic in the last month without getting torpedoed because submarines couldn't hear them?" Archer didn't answer. "Someday doesn't matter," Wade said quietly. "Today does." He left. Archer sat alone in his office, surrounded by technical reports and implementation schedules, thinking about convoys crossing dark water in silence. about U-boats listening to empty ocean, about men who would live because someone paid attention to how oil-soaked rags absorbed vibration. Outside, the shipyard continued its work: welding, construction, repair. The machinery of war turning, indifferent to individual contribution. But the math had changed, and the Atlantic was becoming survivable again. End of Chapter 6. Chapter 7. The Invisible Victory. August 12, 1943, North Atlantic. The numbers told the story that headlines never would. In May 1943, before full implementation of the Archer dampening system, Allied convoy losses in the North Atlantic averaged 27 ships per month. By August, that number had dropped to 8. U-boat kill rates, the measure of effectiveness that Admiral Dönitz watched obsessively, collapsed from an average of 6 ships sunk per submarine patrol to less than 2. The strategic impact was even more significant. Britain's fuel reserves, which had been falling dangerously low in early 1943, stabilized by summer. American troops and equipment crossed the Atlantic in numbers that would have been impossible 6 months earlier. The supplies that sustained the Allied war effort, ammunition, food, vehicles, aircraft, flowed uninterrupted across convoy routes that had been killing grounds. The Battle of the Atlantic didn't end with a surrender or a dramatic final engagement. It ended with mathematics. The acoustic dampening system reduced detection ranges enough that U-boats could no longer position themselves effectively. Without advance warning, without time to calculate intercept courses, the submarines lost their primary tactical advantage. German Naval Command tried to adapt. They increased patrol densities, deployed boats in tighter formations, relied more on visual spotting than acoustic tracking. But the Atlantic was vast, and even 100 submarines couldn't blanket enough ocean to compensate for losing 2/3 of their detection range. By September 1943, Dönitz was withdrawing boats from the North Atlantic. The losses, submarines sunk by escorts they never heard coming, had become unsustainable. The weapon that nearly starved Britain into submission was being forced into defensive operations. The Allies had won, and almost nobody knew why. October 1943, Philadelphia Naval Shipyard. The official report, published by the Bureau of Ships and stamped restricted, ran to 47 pages. It detailed the development, testing, and implementation of acoustic dampening systems across the U.S. Atlantic Fleet. The technical specifications were precise: cotton duck canvas, SAE 30-weight motor oil, compression ratios calibrated for diesel engine mounts rated between 1,200 and 2,400 horsepower. The document credited Lieutenant James Morrison as primary engineer. Chief Petty Officer Howard Wade received recognition for field testing oversight. The Naval Research Laboratory was acknowledged for acoustical analysis. Rear Admiral Cochrane was noted for strategic implementation. Raymond Archer appeared on page 31 in a subsection titled Technical Support Personnel. His name was listed among 17 other machinists, technicians, and logistics officers who had contributed to various phases of development. One line: MM2 Raymond Archer, Acoustic Systems Liaison Installation Protocols. Morrison had fought for more. He'd argued that Archer deserved primary credit, that the entire system originated from his observation and unauthorized testing. But the Bureau had been clear. Official documentation required institutional attribution. Individual sailors, regardless of contribution, were not the face of naval innovation. Wade had delivered the news to Archer personally, expecting anger or at least disappointment. Archer had shrugged. Does the system work? Across the entire fleet. Then the report's accurate enough. Now, in October, with the Atlantic battle effectively won, Morrison sat in his office reviewing deployment statistics and thinking about how history would remember this moment. Future naval historians would analyze the convoy battles, the U-boat tactics, the strategic turning points. They would note that mid-1943 marked the decisive shift in the Atlantic. But they would attribute it to accumulated advantages: improved radar, better tactics, more escorts, enhanced anti-submarine weapons. The acoustic dampening system would be mentioned as one factor among many, a technical improvement that contributed to overall success. And the man who'd actually solved the problem would vanish into the footnotes, if he appeared at all. Morrison pulled out a sheet of official stationery and began writing a letter. It would go into Archer's service record, a formal commendation for technical innovation and dedication to duty. Not a medal, not public recognition, but something permanent. It was the least he could do. December 1943, Technical Standards Committee meeting. The conference room in Washington held representatives from the Bureau of Ships, the Naval Research Laboratory, and 3 civilian engineering firms. The topic: standardization of acoustic dampening systems for new construction. The discussion had been running for 2 hours, engineers debating material specifications, replacement intervals, quality control measures. The Archer system, though it was never called that officially, had proven itself in combat. Now it needed to be formalized, engineered into ship designs from the keel up rather than retrofitted onto existing vessels. A civilian engineer from General Electric proposed a modified version using synthetic dampening compounds, with properties similar to oil-saturated cotton, but with better longevity and consistency. Estimated cost per installation, someone asked. Approximately $400 per engine mount, compared to $5 for cotton and oil. The committee debated. The synthetic version would be more reliable, easier to quality control, better documented. It would also be more expensive and take longer to manufacture, and it would move the solution away from the field-expedient simplicity that had made rapid deployment possible. In the end, they compromised. New construction would use the synthetic system. Existing ships would continue using the Archer method until refit. Both would be designated as standard acoustic dampening, Type A and Type B. The cotton rags and motor oil would remain in service for the rest of the war, protecting thousands of sailors who would never know the name of the man who developed the system. But the official engineering documentation would cite the synthetic version as the definitive solution, relegating the original to interim field application. Progress, as always, belonged to the institution. March 1945, South Pacific. The war in Europe was ending. Germany would surrender in weeks, but the Pacific campaign continued, and the acoustic dampening system had followed the fleet across 2 oceans. Destroyer escorts operating against Japanese submarines used the same oil-soaked rags that Atlantic convoy ships had relied on 2 years earlier. The tactical advantage remained: reduced detection ranges, improved survivability, fewer losses to torpedo attack. By now, the system was simply part of standard procedure. New sailors learned it during training, installed it during maintenance cycles, replaced it according to schedule. Nobody questioned where it came from. It was just how things were done. Archer, now a machinist's mate first class, had spent the last year training crews at the San Diego Naval Base. The work was repetitive, teaching the same procedures to different groups, answering the same questions, troubleshooting the same problems. But every class represented another ship that would cross dangerous water with better odds of survival. He'd stopped thinking about recognition years ago. The work was its own reward: problems identified, solutions tested, lives saved. Everything else was institutional theater. In April 1945, Germany surrendered. In August, Japan followed. The war ended and the fleet began the long process of demobilization. Thousands of ships returned to port. their acoustic dampening systems still in place, still functional, still protecting crews during the journey home. The oil rags would be removed during decommissioning, disposed of with other expendable materials, forgotten as the ships themselves were mothballed or scrapped. The system that had helped win the Battle of the Atlantic would disappear with the ships it protected, becoming a technical footnote in maintenance logs and engineering reports. By 1946, the synthetic Type A system had replaced nearly all field installations. The Type B designation, the original Archer method, was officially deprecated, removed from active documentation, relegated to historical archives. The man and his solution both faded into the machinery of institutional memory. June 1946, Philadelphia. Raymond Archer received his discharge papers at the Philadelphia Naval Yard, the same facility where he'd mopped floors 4 years earlier. He was 36 years old, a civilian again, with a service record that noted technical competence and several commendations for training excellence. Chief Wade, now retired himself, met him at the gate. "Got plans?" Wade asked. "My father's garage back in Pennsylvania. He needs help with the business. From saving the Atlantic Fleet to fixing tractors." Archer smiled slightly. Same work, different scale. They walked toward the parking lot, past buildings where engineers still developed weapons systems and where maintenance crews still kept the peacetime Navy functional. The war was over, but the machinery continued. "You ever regret it?" Wade asked. "The lack of recognition?" "No," Archer minted. "I saw a problem, I fixed it, that's enough." "Most men wouldn't think so. Most men need their name on things to feel like they matter." Archer stopped at his car, an old Ford his father had kept running during the war. "I just need to know the fix worked." Wade extended his hand. "It did, more than you'll ever know." They shook hands. Then Archer got in his car and drove away from the shipyard, back toward Pennsylvania, back toward a life of repairing machinery that nobody would write reports about. Behind him, the Navy continued its work. Engineers refined the acoustic systems he'd pioneered. Officers received commendations for innovations they'd supervised. The institution absorbed the victory and moved forward, as institutions always do. The Battle of the Atlantic was won. The convoys had survived. And the man who'd made it possible went home to fix tractors. Chapter 8, Echoes. November 1982, Naval History Archives, Washington, D.C. Dr. Sarah Chen was 3 years into her doctoral research on Atlantic convoy operations when she found the name. It appeared in a declassified technical report from 1943, buried in a subsection about maintenance procedures. MM2 Raymond Archer, Acoustic Systems Liaison Installation Protocols. The reference was brief, almost dismissive, but something about it caught her attention. She cross-referenced the name with other documents. Personnel records showed Archer had been promoted twice during 1943, transferred to technical training, received 2 commendations. His service record noted significant contribution to acoustic countermeasures, but provided no details. Chen dug deeper. She found the original test documentation from March 1943, handwritten notes in careful block letters describing oil-saturated cotton rags and their vibration-dampening properties. The signature at the bottom, R. Archer, MM3. Then she found Lieutenant Morrison's letter, written in October 1943, recommending Archer for formal recognition. The letter was precise in its language. Petty Officer Archer's observation and unauthorized testing of improvised dampening materials resulted in the development of the acoustic suppression system currently deployed across the Atlantic Fleet. His contribution to the survival of convoy operations cannot be overstated. The letter had been filed and forgotten. Chen spent 6 months reconstructing the timeline. The convoy statistics, the U-boat reports, the deployment records. She documented how a maintenance worker's experiment with shop rags had cascaded into a strategic advantage that helped win the Battle of the Atlantic. She tried to find Archer himself. The trail ended in 1978, a death certificate from a small town in Pennsylvania. Raymond Archer, age 68, retired mechanic. The obituary mentioned his Navy service briefly, veteran of World War II. No mention of the Atlantic convoys. No mention of acoustic systems. No mention of the thousands of sailors whose lives he'd saved. Chen published her dissertation in 1985. It was well received in academic circles, cited by other researchers, and eventually absorbed into the larger historical narrative of the Atlantic campaign. Archer's name appeared in subsequent books and articles about convoy operations, usually in a paragraph or two, noting the development of acoustic dampening technology. But he never became famous. His story never reached the popular histories or the documentary films. He remained what he'd always been, a footnote in someone else's war.